sklearn, model selection, stratified group k-fold. Description: stratified group k-fold is a cross-validation strategy that ensures that each fold has approximately the same percentage of samples from each target class while maintaining the group structure. This is particularly useful when dealing with data that has a strong grouping structure, such as time series data or data with individuals grouped together. Inputs: N splits the number of folds to create. Shuffle whether to shuffle the data before splitting. Random state the random seed for shuffling. Outputs: split a generator that yields indices for each fold. Steps: the data is split into groups. The data within each group is stratified based on the target variable. The groups are shuffled. The data is divided into folds, ensuring that each fold has approximately the same percentage of samples from each target class. Within each group. Metrics: accuracy, the proportion of correctly classified samples. Precision, the proportion of correctly classified positive samples. Recall, the proportion of positive samples that were correctly classified. F1 score, the harmonic mean of precision and recall. Visualization plots. Confusion matrix visualizes the classification performance by showing the number of true positives, true negatives, false positives, and false negatives. ROC curve plots the true positive rate against the false positive rate for different classification thresholds. Precision recall curve plots the precision against the recall for different classification thresholds. Fine-tune parameters. N splits the number of folds to create. Shuffle whether to shuffle the data before splitting. Random state the random seed for shuffling. Uncertainty methods. Bootstrapping repeatedly resamples the data with replacement and calculates the performance metric for each resample. The distribution of the metric can then be used to estimate the uncertainty. Cross-validation splits the data into folds and calculates the performance metric for each fold. The distribution of the metric across the folds can then be used to estimate the uncertainty. Challenges and fixes. Challenge 1: imbalanced groups. If the groups are imbalanced, i.e., some groups have significantly more samples than others, the folds may not be representative of the overall data distribution. Sample use case that resulted in challenge 1: a dataset with time series data where some time periods have many more samples than others. Fixes to challenge 1: consider oversampling or undersampling techniques to balance the group sizes. Challenge 2: small group sizes. If the groups are very small, it may be difficult to create folds that are representative of the overall data distribution. Sample use case that resulted in challenge 2: a dataset with individuals grouped together, where some groups have only a few individuals. Fixes to challenge 2: consider increasing the group size by combining similar groups or using a different cross-validation strategy, such as leave one group out logo cross-validation.